Good morning all. Today we are going to see ordinary differential equation, which is unit 2 in engineering mathematics 1. So first of all we will see the definition of a linear differential equation. The general linear differential equation of order n is of the form d power n y divided by d x power n plus a1 d power n minus 1 divided by dx power n minus 1 into y plus etc plus a and y, which equals f of x. Note this is equation 1. Here a1, a2, etc. an denote the real constant, and equation 1 can be written in the operator form. So we are converting this differential form into by d power n plus a1 d power n minus 1 plus an. So we'll take the y as a common outside, which equals f of x. Usually this equation consists of two parts, which is complementary function and particular integral. So we will define in this video as a complementary function and particular integral. Okay, here we'll denote the formula y equal yc plus yp. Here yc denoting the complementary function and yp is denoting particular integral. So in particular we are going to see complementary function as a first topic. Okay, see the definition here. To find the complementary function, we have to form the auxiliary equation, which is obtained by putting d is equal to m and f of x is equal to 0. So we are just converting the differential form into quadratic function as a m. So here see the case 1. So there are three cases in this. We'll see explain three cases in this. So first case 1. If all the roots m1, m2, etc. mn are real and different, then the complementary function is, which means the element of a, b, c, so the value of a, b, c all are different, means we'll use this formula. See the formula yc equal a e power m1x, b e power m2x plus c e power m3x plus etc. So for example, here we are denoting exponential form in our right hand side. So see the example, d square y by dx square minus 4y equals 6 e power 5x. So our question is of the form in exponential form. If it is exponential form, we will use the case 1 formula. Okay, just to see the questions given. Take this in the operator form, d square minus 4 into y equal 6 e power 5x. So the auxiliary equation is, so just convert d into m square minus 4 equal to 0. Bring this 4 to the next side, so it will become plus 4. So take square root on both sides, we will get m equal plus 2 minus 2. See the both the numbers are different, which is plus 2 and minus 2, the symbol also different. So the complementary function is of the form a e power 2x plus b e power minus 2x. Because both the elements are different, we are using this formula. This is our case 1. Now we are moving to case 2. If any two roots are equal, say m1 equal m2 equal m, then the complementary function is, so we usually use complementary function as yc. The formula is ax plus b into e power mx. So our both the value of a and b are same, then we will use case 2. See the example, d square minus 2d plus 1 into y equal e power x plus 1 the whole square. So just in solution write the given term as it is. So the auxiliary equation will become, change d into m square minus 2m plus 1 equal to 0. So we know that the formula of a plus b the whole square equal to a square plus b square minus 2ab. So convert this into m minus 1 the whole square equal to 0. Take square root on both sides, we will get the value of m equal 1 comma 1. See here in this, the value of m, both the value are equal. So we are using case 2 formula. So the complementary function ax plus b the whole into e power x, e power mx, the value of m equal 1. So we get the solution as it is. Now we are moving to case 3. See, If the roots are imaginary, say m1 equal alpha plus I beta, m2 equal alpha minus I beta, then the complementary function is, so we are having the real term and also the imaginary term. We are using the case 3 formula, yc equal e power alpha x into a cos beta x plus b sin beta x. See the example, d square plus 2d plus 5 into y equals 15. So write the given term as it is. Convert this into the auxiliary equation, m square plus 2m plus 5 equal to 0. So we are using the quadratic equation to find the solution. A equal 1, b equal 2 and c equal to 5. So the formula is m equal minus b plus or minus root of b square minus 4ac divided by 2a. So the value of b is 2. So minus 2 plus or minus root of b square, which means 2 square 4. So formula minus 4 into value of a is 1 and the value of c is 5. Divided by 2 into value of a is 1. So now simplify it, minus 2 plus or minus root of 4 minus 4 5s are 20 divided by 2 1s are 2. So minus 2 plus or minus root of 4 minus 20 will become minus 16 divided by 2, which equals minus 2 plus or minus. So the value of root 16 is 4 and also there is minus inside the root, so it will become I divided by 2. Take 2 common outside in your numerator. 2 of minus 1 plus or minus 2i divided by 2. Cancel 2 on the numerator and also on the denominator. So we will get the value of m as minus 1 plus or minus 2i. Therefore the complementary function, we already know the formula e power alpha x. So here the value of alpha is 1. So it will become e power minus x. A cos beta x. See here the value of beta is 2. So a cos 2x plus b sin 2x. So this is our case 3 formula. So here we denoted 3 cases in complementary function. Once again I will repeat. In case 1, if all the value elements are different, means we use this case 1 formula. In case 2, if all the elements of m is equal, then we will use the case 2 formula. Suppose if your equation is of the form in real and imaginary, we will use case 3 formula. Okay, next we are moving on to the next part, that is particular integral. In this there is a 4 time we are mentioning in this class. See in this type 1. So f of x equal e power ax. So my term is on the exponential form. Then the particular integral equal 1 by pi of d into e power ax. Just note this as equation 1. Convert d into a. So it will become 1 divided by pi of a into e power ax, provided pi of a not equal to 0. So our denominator should not equal to 0. Okay. If it is, means we will stop the process here itself. Suppose our denominator is equal to 0. So if pi of a equal to 0, then our first equation will become, so just to differentiate this, what we will get, particular integral equal x into 1 by pi of d into e power x, x into 1 divided by pi dash of d, because we are differentiating equation 1 with respect to x. Again we will convert this d into a. So our next step is x into 1 divided by pi dash of a into e power x. This also provided pi dash of a is not equal to 0. Same, the denominator should not equal to 0. If it is, means we will stop the process here itself, or else we will move on to the next step. As if pi of a equal to 0, then a particular integral will become, so next to the equation changing, taking differentiation in this, x square into 1 divided by pi double dash a d into e power ax, again changing this d as a, and so on. So the process will go on like that. So this is our type 1. We'll see the example in this. I'm taking 2 example for this type. Because for pi of a is not equal to 0, we will see how our equation will be. If suppose pi of a is equal to 0, then how our equation will be. See in our example 1, so there is a question, d square minus 4 into y equal 6 e power 5x. So just in our solution, take the given equation as it is. Here we are going to see the particular integral. Before we will see in the complementary function, we find the auxiliary equation, but here we are going to use the particular integral. So keep y as it is in the left hand side, bring the d square minus 4 into the next side. So it will become division. So 1 divided by d square minus 4 into e power 5x. So we are going to find the particular integral. So here the value of d equals 5. See in this exponential form, e power 5x. So our value of a is equal 5. So convert d into a. So 1 divided by d square, which means 5 square minus 4 into 6 e power 5x. So the value of 5 square is 25 minus 4 into 6 e power 5x, which equals 6 divided by 25 minus 4 is 21 into e power 5x. So 6 divided by 21. So both the numerator and denominator are divisible by third equation. So cancel it. So 2 times 3 is 6. 7 times 3 is 21. So our equation become 2 by 7 into e power 5x. See in this equation our denominator. So 25 minus 4, which is not equal to 0. We get the answer as 21. So we stop the process here itself. See in our example 2, it is different. D square minus 9 into y equal e power minus 3x. So in this exponential, the value of a is minus 3. So take the given equation and particular integral 1 divided by d square minus 9 into e power minus 3x. Mark this as first equation. So here the value of a is minus 3. Which equals 1 divided by minus 3 the whole square minus 9 into e power minus 3x. So the value of 3 square is 9. So minus square it will become plus. So 9 minus 9 into e power minus 3x. See in this my denominator is 0. So our denominator should not equal to 0 means we will stop the process as it is in example 1, but here my denominator is 0, so I am moving on to the next step by differentiating equation 1. See from equation 1 I am differentiating with respect to x. X into 1 divided by, so d square become 2d, so minus 9. 9 is a constant, so it will not come, into e power minus 3x. So x divided by 2 into, so the value of d is minus 3. So the value of d, which is equal to a, that is minus 3. So 2 into minus 3 e power minus 3x. So x divided by 2 3s are 6. Take the minus outside. So minus x by 6 into e power minus 3x. So this will continue if my denominator is equal to 0. Okay, now we are going to see the type 2 in particular integral. F of x equal to sin ax or cos ax. Then particular integral equal to 1 by pi of d into sin ax or cos ax. So in first type we changed, we replacing d by a, but in type 2, so here it denoting sin and cos. So we are changing d square by minus a square. Note it, d square by minus a square, not d. So in pi of d replace d square by a square provided pi of d not equal to 0. Same, our denominator should not equal to 0. Suppose if it is equal to 0, then we will differentiate equation 1. So see, particular integral equals 1 x into differentiating with respect to x. So 1 divided by pi dash of d into sin ax or cos ax, provided pi dash of d not equal to 0. Suppose if it is equal to 0, then differentiate again. It will become x square into 1 divided by pi double dash of d into sin ax or cos ax and so on. See the example. D square minus 3d plus 2 into y equal cos 3x. So take the given equation and particular integral, it will become in denominator. So the value of d square is minus 3 square. So the value of a is 3. So it become minus 3 square. Change d square by minus 3 square. It will become 1 divided by minus 9 minus 3d plus 2 into cos 3x. Minus 9 plus 2 is minus 7 minus 3d. Take minus outside. It will become 1 divided by 3d plus 7 into cos 3x. So multiply both the numerator and denominator by 3d minus 7. Next, we know in the denominator using the formula a plus b into a minus b equal a square minus b square. So my a square become 9d square minus b square become 49. So the remaining and all as it is. Next 7 minus 3d divided by, we already know that d square equal minus 9. Substitute it, then we'll find 9 into 9 81, so there is minus in that. So minus 81 minus 49 numerator. Just multiply cos 3x in both the terms. So 7 cos 3x minus 3 3d. We already know that the value of d is minus 3. So minus into minus plus 3 into 3 9 sin 3x. So it's a differentiation form of cos 3x is minus sin 3x. So the value of 3 into 3 is 9. So in our denominator minus 81 minus 49 to become 130, right? Yes, 130 minus 1 by 130. So in the bracket 7 cos x plus 9 sin 3x. That's it. In our type 3, we are going to see f of x into e power ax into x. Here x denoting sin ax or cos ax or x power n. See, in our type 1 we see only the exponential form. In type 2 we see sin ax or cos ax. In type 3 we are combining both the terms. See how our equation will become. Particular integral equal 1 by pi of d into e power ax into x. So convert d by d plus a. So in the exponential form we converting d by a. In sin or cos ax we converting d square by minus a square. In type 3 we are converting d by d plus a. So my d is replaced by d plus a. Again we are continuing type 1 or type 2 basing on the questions. See in example, d square minus 2d plus 5 into y equal e power 2x into sin x. Write the equation as it is given. Particular integral 1 by d square minus 2d plus 5 into e power 2x sin x. So take exponential form first, divided by, we already know that we are using the formula d by d plus a. So there is exponential form and also the sine form. So we are changing d by d plus a. So here the value of a is 2. See, e power ax. So value of a equal 2. So d plus 2 the whole square minus 2 of d plus 2 plus 5 into sin x. So by simplifying we get d square plus 2d plus 5 into sin x. We already know that. So now we are moving to the next step. So there is a sine term in this. So we are using the type 2 formula, which is changing d square by minus a square. So the value of a sin x. So the value of a is 1. So minus 1 square, which is minus 1. 1 divided by minus 1 plus 2d. So we are converting only d square, not d. So minus 1 plus 2d plus 5 into sin x. So e power 2x equal 1 by 5 minus 1 is 4. 2d plus 4 into sin x. Okay. Next, multiplying both the numerator and denominator by 2d minus 4. Again a plus b, a minus b will become a square minus b square. So change your denominator as 4d square minus 16. Again I am converting this d square into an form. So d square equal minus 1, we already know that. So 4 into minus 1 minus 16 into sin x. So it will numerator as it is 2d minus 4, denominator will become minus 20 into sin x. So take your minus 20 outside, e power 2x divided by 20. Next, 2 differentiation of sin x, which is cos x minus 4 into sin x. So this is our type 3 equations. Next we lost type. So type 4, f of x equal x power n into sin ax or x power n into cos ax. In type 1 we saw exponential form, type 2 we saw sin ax or cos ax, in type 3 we saw both exponential or sin or cos ax. In type 4 we are going to see x power n into sin ax or x power n into cos ax. Our particular integral will become 1 by f of d x power n sin ax or x power n cos ax. Okay, so my equation, see how it is changing. X power n cos ax plus I sin ax, changing this into e power iax. Again in this we are changing d divided d, replacing d by d plus ia. Okay, so imaginary part is sin ax and real part is cos ax. See the example, d square minus 2d plus 1 into y equal x sin 3x. Take the equation as it is. Your particular integral will become 1 divided by d square minus 2d plus 1 into x sin x. Here our question is in sin x, which is imaginary part. So particular integral will become imaginary part of 1 divided by d square minus 2d plus 1 into x cos x plus I sin x. We already known that. We change this into e power iax. The value of a is 1, so just write e power ix. So take e power ix in front divided by, so in this we are going to change d by d plus ai. The value of a is 1, so d equal d plus I. Just convert d into d plus I. So your d square become d plus I the whole square minus 2 into d plus I plus 1 into x. So just to simplify it, we get 1 divided by d square minus 2 of 1 minus I into d minus 2i. So take minus 2i as a common, so you get 1 plus the second term. So your first term become e power ix divided by minus 2i, and the next term is 1 divided by 1 minus d square minus 2 of 1 plus I into d divided by 2i into x. So bring this denominator into numerator, it will become reciprocal, right? So the whole power minus 1. Again convert this minus 1 in multiply it, so 1 plus d square minus 2 of 1 plus I into d divided by 2i plus so on. Okay, and again you simplify it, you get the equation. See in the third last step, imaginary part of I by 2, again taking e power ix into cos x plus I sin x, x plus 1 into I. So keep constant outside, so 1 by 2 outside. Next just multiply these two terms which is in the bracket, I cos x minus sin x into x plus 1 into I. By multiplying both the terms we will get the equation as 1 by 2 x cos x plus 1 by 2 cos x minus 1 by 2 sin x. So in this session we see that the ordinary differential equation which containing two parts, which is complementary function and particular integration. We also see their types in this. We will see the variation method of variation of parameter in the next class. Thank you all.